Hi everyone, here is chapter 12, urinary system. And this is the system that makes urine. The digestive system makes feces and the urinary system makes urine. So let's start. So basically the urinary system is in charge of cleaning out your blood. That's how it makes urine, is by filtering your blood. And it's always changing. So every time you use the bathroom and have urine, it's going to have a different chemical makeup. Our body weight's about half fluid, and so that's what our urinary system is working to clean. So any tissue fluid, blood plasma, which is the yellow stuff in your blood we learned about, lymph from your lymph nodes, and other fluids, those are all going to get filtered. They're called extracellular fluid. They're going to get filtered through the urinary system. So here's your total body fluids here on the bottom. Your intracellular fluid, that's going to stay. Your extracellular fluid is composed of those things. Intracellular would be like inside cells, and then extracellular would be outside cells. And so on any given day, this is the average human, so it's not specifying males or females. In your as solids, like in your food, you're getting about 850 milliliters, which is about, so I have this little water bottle thing here. This is about 40 ounces and 1 liter is 30 ounces. So I would say 850 mils. I'm doing a lot of conversions in my head, sorry. It's about half of this, a little more than half is probably 850 mils. And then this whole thing ingested as liquids would, a little bit more than this would be the 1400 ingested as liquids. And then metabolically derived, that's from chemical reactions in your cells. So all total, you're getting about 2,600 milliliters, just 2.5 liters. And you should hopefully lose the same amount. So you lose most of the water in your urine, some of it in your feces, because your feces aren't totally dry, hopefully, right? Your large intestines aren't doing that good a job. And then evaporation, like sweating. So you should be equal here. If not, you're going to get like bloated or dehydrated. So the in should equal the out. So body takes in about the same as it's lost. If you don't have enough, you're thirsty. If you have too much, you're going to urinate more to get rid of it. So that's how it kind of fine tunes how much you need, or through sweat too. So urine is how we get rid of excess water. And there are 3 ways that we can get liquid into our urinary system. We also expel some water when we're exhaling along with carbon dioxide. And then when we sweat, we do also get rid of water and waste that we call urea. So those are, the skin and lungs are actually considered part of the excretory system too, because we do get rid of waste through those methods. So this is showing how the path that waste takes. And if it's solid waste, you make feces. If it's liquid waste, it goes through the urinary system or respiratory. Okay, so the main focus organ of your urinary system are your kidneys. Those are the filters that are doing all the work. They're bean shaped. They're like in your lower back. So if you have pain in your lower back, it's probably just your lower back, but it could be your kidneys. If you have a UTI, urinary tract infection, and then you have lower back pain, it might be your kidneys. And they can do tests to check that. Okay, so let's see. Some of the kidney functions are, they make erythropoietin that causes your bone marrow to make red blood cells. They play a role in converting vitamin D. So we do make vitamin D from UV light from the sun. That's true, but it takes a couple steps to get to become vitamin D. And one of those steps is in your kidney. One of them's in the liver. It also makes renin, which is the substance that helps you with your blood pressure. And then its main job is to make urine. So it removes waste, not just water, but also waste from your blood, and then make sure that your fluid balance is just right. It does this by these little tiny structures called nephrons that are in the kidneys. So these are like the little workers. They're kind of like the alveoli in the lungs, if you remember them. These are the little workers that are actually doing the work and filtering the blood. And so here are the kidneys, and you can see if you like flip the person around, they look a little high in this picture actually. You have 2 of them, so sometimes people have to get their kidneys get a kidney transplant and people will donate one of the kidneys. And then you have adrenal glands on right up above them, and that releases adrenaline. And so what happens is the blood is going to go in, let me see, in and out through the inferior vena cava. And no, it goes in through the aorta and back out through the inferior vena cava anyway. And then filtering is going to happen in there. So it's busy filtering your blood, and then it's going to produce urine. These are called the ureters right here that take the urine, like this is literally urine in the tube, going from the kidneys down to the bladder, and then your urethra is how you expel it out of your body. So that's that tube. Here it is from the backbone, it just nests, your two kidneys nest right around there. And then if you cut them open, you can see these different structures. So you have like the renal cortex on the outside, the renal medulla is the busy part that's filtering, and then you can see the blood going in and out, and then filtering and coming back out. And then if we zoom in further, there's got to be a picture. This is the part of the nephron that we saw before. So this is a picture, not the best picture, but it's a picture showing the little workers that are actually doing the work. I'm just seeing if there's a better one. Nope. Okay. So in the nephron, you have these different parts. One of them is called the glomerulus, and that's a cluster of blood capillaries that I'll show you in the picture. And then you have the Bowman's capsule, which is like a catcher's mitt. And then you have these little tubes. You have proximal tubule, distal tubule, and the loop of Henle. And the blood vessels bring the blood in, through, and out of the nephrons. So there's 3 steps. Filtration happens first. So it filters and it kind of like gets rid of more water than it needs to. And then it reabsorbs water back in. So it kind of like pushes everything out and then brings it back in and brings the water back into your blood and only leaves you with like less urine. And then secretion is getting rid of urine. Okay, so first step is filtration. Remove the large amount of fluid. So it's going to push a lot of liquid out of your blood, too much, and then kind of take some back. So reabsorption is taking some back into the blood, like glucose, amino acids, and electrolytes, and water. So it's going to be pulled back in and put back into the blood. So it's kind of being concentrated. So your urine becomes more concentrated. And that's in response to how much water, like how hydrated you are. And then secretion is the last part, and that's when it gets rid of excess hydrogen, and then it finally forms like the finished product of urine. And then you're going to send that liquid out the ureter. So let's look at this. This is kind of a very computer-generated look at a nephron. So you can Google nephron to see what they really look like in real life. But they're little tiny microscopic structures. The glomerulus is this like red cluster here, and it's just a ball of capillaries. And so what happens is the blood comes through this tube, and then it shoots out the water into this Bowman's capsule. The Bowman's capsule is kind of like a catcher's mitt, and then the glomerulus is like the ball. So it's going to shoot out the liquid, and so that's the filtration part. While it's doing that, it's going to do the reabsorption part, where some of the salts are going to be taken back into the blood. Do you see this? You have like NaCl, K+. Those are being reabsorbed into this little capillary. So that is reabsorption. And then secretion is when these H+s are moved back in. So it's kind of like adjusting exactly what needs to be in and out. So it does that all along the way. Different things happen in the loop of Henle on each side. H2O can return back to the blood in the descending loop of Henle, and then sodium returns. And then it keeps going through the distal tubule to the collecting duct. We're still part of the nephron. We're still deep in the kidney. But here, water can also return to the blood. So it's like fine-tuning, like how much urine do you need? And millions of little nephrons are doing this at the same time. And then it's going to be beta to urine. So when this goes through, not very much water, like let's say 180 liters of water daily is filtered. So you just keep filtering and filtering and filtering. Only 1% is going to turn into urine. The rest is going to be put back into your blood. And then none of the glucose should be excreted. So you know how when people have diabetes, their urine gets checked for sugar? That's because that's a sign that your kidneys aren't working, and your kidneys should not be giving up glucose. You should not be peeing out sugar. Like none of it should come out. Some of these are signs of high blood pressure too, like amino acids. You're only supposed to excrete 5%. If you have high protein in your urine, that's a sign that you have high blood pressure because the blood is pushing too hard on the glomerulus and pushing too much stuff out into the Bowman's capsule. And then a little bit of sodium gets excreted, and then quite a bit of urea. Urea is like breakdown from proteins. It's waste. It's what urine's made out of. So like half of the urea is excreted. So urination is fortunately voluntary and not involuntary. So we're not like peeing our pants all the time. But as the bladder fills, we can feel it filling. It's made of smooth muscle. But we have control over whether it comes out or not. That part is voluntary. So here's the bladder. You have these sphincters, just like in your esophagus, to your stomach, that help like keep your urine from not leaking out. Sometimes it still does. And then there's a certain amount, I don't remember what it is, but there's like a certain amount of urine in your bladder normally where you like start to feel like you have to go. So once it reaches that threshold, then that feels like you have to go for most people, but people's bladders can be like stretched out. They can have medical problems and have issues. Their sphincters aren't working, all of those things. Let's see. Okay, so total body fluid should stay the same. You shouldn't be taking on extra fluid. You should be even, or you're going to get like bloated. The loop of Henle doesn't let water pass through, but it absorbs or it transports sodium out. So here, okay, this is a better look at what a nephron looks like. So this little ball here, that's the Bowman's capsule, and then the capillaries going in would be the glomerulus. And then the liquid from the blood is going to travel through and stuff is going to move in and out. So here on this side, water can leave, and then on this side, salt can leave. So this is all controlled by hormones, just like everything else. So you have antidiuretic hormone you might have heard of, and that can be a diuretic. You might have heard of that word. Controls the salt in your body and thus controls how much urine you pee. And then aldosterone controls, it causes it to reabsorb sodium. So hormones are acting on you. Here is the nephron again. There is your glomerulus and your Bowman's capsule, and it pushes the fluid out. Stuff comes in and out, and these hormones are acting on them at different times. All of this is controlled by your brain, of course. And so when your body detects that you don't have enough water, so it looks like that's the A, sensors are going to tell your body to release ADH, antidiuretic hormone. It's going to make it here to the distal tubules, which is on this side of the loop of Henle. And that's going to make you leak out more water. So you're going to reabsorb water, meaning it goes back into your blood because you're dehydrated. And then you're going to make less urine. And you know how like when your urine is really concentrated and yellow, you can tell you're dehydrated. And then that cycle just continues. When you are thirsty, there's a thirst center in your brain. It's going to trigger the same response as ADH, makes your mouth feel drier, and then makes you thirsty. Here again is the glomerulus with the Bowman's capsule. And it's showing you how renin acts on it and angiotensin and all these different, it's complicated. There's a lot of little steps that are fine-tuned for this. So normally your blood pH is 7.3 to 7.5, so it's a little bit basic. And urine is one way that we can adjust our pH because it can pull H's back into the blood or out of the blood. And H's are what makes things acidic, little hydrogens. Acids have a low pH, bases have a high pH. And so this is the way for us to fine tune that. Kidneys can also make bicarbonate, which is baking soda, and pump that into the blood. So if your blood is too acidic, the pH is too low, like below 7, you're going to get more bicarbonate from your kidneys. and that's going to raise the pH. And then if it's too high, you're going to pee out the bicarbonate. So what is this? So this is tubule. This is probably in the nephron. And then it can cause like the bicarbonate to move into the bloodstream if it's too acidic. So that'll neutralize it, or vice versa. Okay, so here's some imbalances that people can have. There's metabolic acidosis, where your blood is too acidic, can cause a lot of issues. You're not excreting enough acid, or the opposite is metabolic alkalosis, where your blood is too basic, and these are caused by things like severe diarrhea or vomiting. So they're usually like a result of something else going on. Here's some kidney disorders. Kidney stones you've probably heard of. So in your kidneys, you can get little stones because they're filtering out stuff that can make like minerals, like NaCl can make a salt. And so they can form little stones. And they have to remove those. They can also become lodged, like as your body's trying to pee them out. Maybe they get lodged in the ureter or the bladder or the urethra. I'm recording. You can also have glomerulonephritis, which is those nephrons are damaged and swollen. Could be from chronic high blood pressure. So you're like blasting those glomeruli with high pressure blood. Like that's bad. It's going to rip them up. It's going to rip up the Bowman's capsule. Diabetes can also cause problems. So that's why they're looking at your urine. Like you can tell a lot about what's wrong in your body from your urine. There's also some inherited diseases like this polycystic kidney disease, where you get cysts on your kidneys. You might get a lot of UTIs, and you might end up needing dialysis, which is where they hook you up to a machine and filter your blood. In a machine takes several hours, several times a week for people to do this because their kidneys aren't working, or you're on the list for a kidney transplant. So here's dialysis. This is a polycystic kidney. This can happen to fish too. If you've heard of, I think it's PKD, polycystic. It's the same kidney disorder caused from different things, but it's in fish. So we have a human version. And anyway, they hook you up, they put fluid into you, and then they take fluid out and it filters your blood, and then here they're filtering. So you can also have cancer, urinary cancer. You can have a Wilms tumor, which is a type of cancer. You can get a UTI. For some reason, women are more susceptible. Nephritis, as in nephron, is inflammation of the kidneys from bacteria. It could be from a UTI that leads to kidney inflammation, which you don't want to get. And then painkillers can hurt the kidneys. So watch out for taking too many painkillers, even over the counter, because they hit your liver and kidneys first. And then kidneys can adjust your blood, which we said they can remove nitrogenous waste, which is that urea. They help maintain your water and your pH and get rid of it all in urine. And in the US, 95,000 people are waiting for a kidney transplant. You can volunteer to donate a kidney. They also do paired kidney exchange. It's hard to find a donor that's compatible sometimes. So those are programs that help people. If you want to know more about it, you can look it up. All right, see you later.